Elon Musk asserts that the future of humanity lies on the planet Mars. As the wealthiest individual on Earth, Musk declares his commitment to channeling all his resources toward the ultimate goal of constructing a city on Mars. He envisions a scenario where millions of people will inhabit this Martian city under a colossal space dome, creating a utopian society. Meanwhile, those remaining on Earth are seemingly left behind. While this concept sounds appealing in theory, upon closer examination, doubts arise regarding what Elon Musk might not be disclosing about Mars. Musk often discusses the notion of a unique window in time. Throughout the 3 billion-year history of life on Earth, the current generation stands out as the first with the technological capability to venture beyond our planet. This achievement brings immense responsibility, as the duration of this window remains uncertain. Failing to seize this opportunity could mean losing it forever. Musk proposes sending 1 million individuals to Mars, along with 100 million metric tons of supplies, to establish a self-sustaining city on the Red Planet. This ambitious endeavor entails the deployment of a fleet of 1,000 Starship rockets shuttling between Earth and Mars every 2 years. While the plan appears daunting and carries undertones of intense dedication akin to a cult, it does hold a logical rationale. Why the fixation on Mars? When contemplating an alternative to Earth, our choices are limited. The Moon, although nearby, lacks significant habitable potential. Venus, with its harsh conditions, is inhospitable. Thus, Mars emerges as the most viable option, although requiring substantial development. Musk remains optimistic, envisioning a future where Mars could be transformed into a habitable planet similar to Earth. For instance, Mars does possess an atmosphere, although much thinner than Earth's. However, it still provides more protection than the Moon and lacks the extreme conditions of Venus. Despite its weaker gravity compared to Earth, Mars's gravity is substantially stronger than that of the Moon. The planet boasts abundant natural resources, including water, with evidence suggesting past oceans. Much of this water remains frozen in polar ice caps. Additionally, Mars's distinctive red hue adds to its allure in our solar system, making it the least threatening option for human habitation, although it remains far from safe. Elon Musk has been forthright about the challenges Mars presents. He acknowledges the arduousness of the journey, describing it as cramped, dangerous, and requiring immense effort, with a potential risk of death. While Mars may experience relatively mild temperatures during its equatorial summers, its overall climate is harsh, with average temperatures plunging to -60 degrees Celsius or -76 degrees Fahrenheit. Furthermore, the Martian atmosphere, consisting mostly of carbon dioxide, is extremely thin, offering minimal protection from cosmic radiation. Unlike Earth, Mars lacks the atmospheric shielding necessary to mitigate the harmful effects of cosmic radiation, which poses a significant risk to potential settlers. Moreover, Mars's lower gravity, approximately 1/3 of Earth's, presents both advantages and challenges. While it may aid in mitigating the physical effects of prolonged weightlessness experienced during space travel, it also means that settlers will need to readjust upon returning to Earth. Mars is prone to massive dust storms that can engulf the entire planet, posing a significant hazard to equipment and infrastructure. Managing dust accumulation, particularly on solar panels, will be an ongoing challenge. Elon Musk's cautious outlook reflects the reality of Mars's inhospitable conditions. He acknowledges the likelihood of casualties and emphasizes the narrow margin for error in such a harsh environment. Even Musk himself admits uncertainty about his own survival on Mars, expressing a desire for SpaceX's continuity beyond his lifetime. Despite these challenges, the pursuit of establishing a city on Mars remains the ultimate goal, although one fraught with peril and uncertainty. The envisioned shiny space dome will necessitate robust protection against radiation, micrometeorites, atmospheric exposure, and dust storms. Maintaining such infrastructure in the face of Mars's harsh conditions poses additional logistical challenges, raising questions about the long-term viability of Martian settlements. Mars lacks an active molten core, resulting in the absence of a magnetosphere to shield against cosmic rays and solar winds. The planet's thin atmosphere increases vulnerability to meteorite impacts. On Earth, the dense atmosphere causes meteorites to burn up upon entry due to friction, reducing the size and impact upon reaching the surface. However, on Mars, with atmospheric pressure less than 1% of Earth's, meteorites retain their integrity and velocity upon impact, posing a significant threat to habitats. Moreover, exposure to Mars's low-pressure environment presents challenges for human survival. A breach in habitat integrity could lead to rapid decompression, causing bodily fluids to boil and catastrophic injuries. To mitigate these risks, underground habitats offer a solution. Elon Musk has emphasized the importance of tunneling technology for Mars colonization, envisioning entire cities built beneath the surface to provide radiation shielding. As for sustaining a Martian population, ideas such as Matt Damon's fictional portrayal in The Martian of growing potatoes, using Martian soil and recycled waste, present intriguing possibilities. Martian soil contains essential nutrients for plant growth, including oxygen, hydrogen, nitrogen, carbon, potassium, and phosphorus. While Martian soil lacks organic matter found on Earth, advancements in hydroponics and soil cultivation techniques could enable agricultural viability on Mars. However, the absence of Martian soil samples poses a challenge, requiring further exploration and experimentation to confirm its suitability for agriculture. In summary, Mars's environmental challenges necessitate innovative solutions for habitat protection and food production. While underground habitats offer safety from radiation and meteorite impacts, agricultural techniques tailored to Martian conditions hold promise for sustaining human life on the Red Planet. In The Martian, Matt Damon's character resorts to using his own waste to fertilize his potato farm, reflecting a real-life scenario where experiments have been conducted to grow plants in simulated Moon and Mars soil. Surprisingly, plants cultivated in simulated Mars soil outperformed those in the Moon soil, even matching or surpassing the Earth soil control group in biomass production. However, recent discoveries of calcium perchlorate in Martian soil complicate matters, as this salt can be toxic to plants in high concentrations. The presence of perchlorate raises concerns about the safety and feasibility of cultivating crops on Mars. Considering these challenges, it's understandable to question the wisdom of Martian colonization. The vision of underground cities and scarce food resources evokes dystopian imagery reminiscent of Blade Runner. In the film, off-world colonies are marketed as havens of opportunity, but the reality may be far harsher, akin to the perilous European settlement of North America. While some pioneers thrived, many faced starvation, conflict with indigenous populations, and other dangers. Despite the uncertainties, the allure of exploring new frontiers remains strong. Elon Musk acknowledges the risks but emphasizes the excitement of the endeavor. Just as past generations ventured into the unknown, perhaps humanity is ready to embark on a new chapter of exploration on Mars. Success is far from guaranteed, but the prospect of discovery and adventure fuels the drive to push boundaries once again. What do you think about this? Leave it here in the comments and take the opportunity to like the video and subscribe to the channel for more videos like this.